So today we're going to talk about special triangles in the unit circle. The learning goal is I'm learning to use the unit circle to find the exact trig values. So from a previous lesson, we talked about our special triangles, and we talked about how we build this triangle. So we had this as 1 and 1 and root 2. We built this up as 1, 2, root 3. And the 60-degree triangle is just a rotation of the 30. So this was 1, 2, and root 3. And one thing we also talked about is the idea is if we wanted to make our radius 1, which is the hypotenuse, we could just divide the radius by these sides to be 1 over root 2, 1 over root 2, and 1. I could divide that by 2, divide this one by 2, and this being 1, and likewise I can make these halves and 1. So we're going to use these trig ratios and talking about how does this relate to a tool that we can use to memorize some of these things. So the unit circle is a memory aid diagram that shows information about commonly referenced angles in trigonometry. It uses symmetry and special angles to store this information. So as you can see, the first one here, if I went up to this triangle here, all right, that root 3 and root 2, or root 3 over 2 and 1/2, were my x and y coordinates on our circle. And our x coordinate is going to represent cos theta, which you can see here is 1/2, and sine theta. And that's a neat way of kind of storing that in our calculator, or in our unit circle. We'll do the same thing with 45. We'll do the same thing with 30. However, the unit circle also does stuff with other angles that are important. For example, 90 degrees, well, that point is 1, 0. Well, cos of 90 is 1. The cos of sine of 90 is 0. Same thing down here. We have 0, 1 at 0 degrees. This point would be, sorry, I messed that up. 0, 1 here. 1, 0 here. Negative 1, 0 here at 180 degrees. And down here is 0, negative 1 at 270. That's where we're going to take from this unit circle, and we're going to build the unit circle on the next graph. But the big idea here is we can talk about on this unit circle, all right, the point xy is going to represent what cos theta is and what sine theta is. So we were going to know the certain angle is going to give us the cos and sine function of that ratio to figure that out. And then we're going to use symmetry, which talks about Kath's law, and we know that's going to be symmetrical in each of the quadrants. And we're going to show that on this next page. So we've got a blank unit circle. So I'm going to use 3 different colors to kind of highlight the different quadrants that I'm in. So the first one I'm going to use, all right, I'm going to talk about this 45-degree angle here. All right, and if I was drawing this out using some colors here, all right, I got my green here and here, all right, and there's my 45s here and here. All right, and if we were looking at this, our 45 up to there is the same up to there, which is the same down to there, which is the same down to there. And the only thing that's going to change these points, 1 over root 2, 1 over root 2, because that's what cos of 45 and the sine of 45 is our cast law. And we're going to come back to these in a second. So 135, this one was 225 down here, and this one is 315 down here. Okay, we're going to build this first quadrant first, and then we'll figure out the other pieces in a second. The next angle we're going to talk about is our 30-degree angle. So it's this piece and straight across there and straight across there. And if I was looking at 30 degrees, all right, I can actually draw this down here. All right, this is my 1/2. This is my root 3 over 2. So that's root 3 over 2 and 1/2, because that's where cos of 30 degrees and sine of 30 degrees. All right. And then we'll go up to our 60s. So let's do 60 all the way up there. All right, and we know that 60, the ratio, these change, right? Because it's just the 30-degree triangle rotated up to the 60-degree triangle. So this becomes 1/2, this becomes root 3 over 2. So that point is just 1/2, root 3 over 2. So cos of 60 degrees, sine of 60 degrees. Okay? So to find all the rest of these points over here, and over here, we're going to use cast law. I'm trying to find a different marker here. All right, so we know all are positive here, sine is positive here, tangent is positive here, and cosine is positive there. So if I was looking at my 45-degree angle, all right, our sine is positive, so 1 over root 2, but our cosine is negative. All right, and if you look at it here, right, I've gone negative direction to that point. That makes sense. Okay? Likewise, if I was doing the 120-degree angle, that's 60 degrees up. So it's the same angle as that, but the x value is negative and the y value is positive. And hopefully as you're building these, that's 30 degrees, that's 150, you will see some similarities. Negative root 3 over 2, positive 1/2, all right? If I went down here, all right, this is where both points are negative, because we're in the positive or negative x direction and the negative y direction. So negative root 3 over 2, negative 1/2, negative 1 over root 2, negative 1 over root 2. And here, my 60 degrees there, that gets me to 240. All right, negative 1/2, negative root 3 over 2. All right, and we can go this way, back down 60 degrees. The x value is positive because it's cosine, and the y value is negative. So that is 300 degrees. 315, the x value is positive, the y value is negative, matches up. All right, and then the last one here, we're down 30 degrees. I've got root 3 over 2 and negative 1/2. All right, but the biggest thing here we want to keep in mind is every point that we have talks about cos theta, sine theta. All right. So there's many different ways of remembering these things and to apply these things. But if you know this quadrant, you can build all the rest of the quadrants based on the CAS rule and what does the x and y coordinates mean, all right? Negative x, positive y up here, negative x, negative y here, positive x, negative y here. So this is a nice tool to remember. It's not always ideal sometimes because you have to build it. And the only other pieces here that we're going to put on here, all right, is where sine and cos are at these points here at 180. So that is negative 1, 0. Here at 270, it's 0, negative 1. And then we're back at 360, still at 1, 0. All right. So if you need to push pause and to getting those copied down, this is the meat and potatoes of the lesson. And now we're going to apply it moving forward. Okay. So how are we going to use these things? Well, we're going to use our primary and secondary trig ratios to determine these things. So one of the things we learned from our trig identities is that tan theta is sine theta over cos theta. All right. We also know our reciprocal functions. All right, we know that. We know that secant theta is 1 over cos theta. And cotangent theta, you could do probably cos theta over sine theta. So you notice they're all related to sine theta or cos theta, or both. That's the things that are really important. We can use these things. Okay, so what does this look like? What I would do is have this sheet out ready to go as we go through these things. All right, so cos of 210, a couple ways of thinking about this. All right, if I was looking at cos of 210, all right, I know it's going to be negative because it's in quadrant 3. All right, and my related angle is 30 degrees. Okay, so I can think about this is I can take this right from the unit circle and find that answer. However, some thinking here is my related angle here is 30 degrees. Cos of 30 degrees is root 3 over 2. And I know I'm in quadrant 3, and this is where cosine is negative. So you can use this from our special triangles, and it still gives us the same answer. Okay? If I was looking at sine of 330, Well, 330 is right here. The sine of this is negative 1/2. I could also think about this as my related angle is 30 degrees. And sine of 30 degrees is 1/2. But in Q4, sine is negative. And I could use my special triangles as well. All right? Both ways. All right? So there are two ways to use this unit circle. We can use this unit circle to find the exact trig ratio without using a calculator. So you notice here we didn't do any work with the calculator. It was all based on understanding the concepts that were built in this circle. Okay? Now, if I look at this, 495. Well, we don't have 495 on this triangle or this page. So we need to find out where that is. Well, maybe we need to think about a coterminal angle. Well, we know that if we take 495, subtract my 360, I can figure that out as 135. So therefore, we can say that the cos of 495 is equal to 135. And then I can go to my unit circle and say, well, cos of 135, I know that's going to be cos of 135. Its related angle is 45 degrees. So I know it has to be 1 over root 2. And in Q2, it's negative. So it's going to be that. So I may have to use some coterminal angles to get it to the unit circle to find that answer. So I might have to do some thinking with this. All right. Sec of 120. Well, I know that secant of 120, I don't know that on my circle. However, I could use this trig identity to change that thinking. So I can think of this as the equivalent of this would be 1 over cos of 120 degrees. Well, if I look at that, all right, now I just have to go to see where cos of 120 is. Well, that related angle is 60 degrees. Well, cos of 60 degrees is 1/2. All right, so I can think of it as cos of 60 degrees is 1/2. All right, but this means in Q2, that's where cos is negative. So we know that this is going to be 1 over that. And then I just have to do the reciprocal. So the reciprocal of negative 1/2 is just negative 2 over 1, or just negative 2. So I may have to use some trig functions to figure out what's going on. All right, my thinking. All right, moving along. All right, cos of 300. Well, maybe I have to think about a coterminal angle. All right, so negative 300 plus 360, that's going to be 60 degrees. So I know that this would be cosecant of 60 degrees. And we know that we want to do the reciprocal, that's the reciprocal of sine. All right, and then I look at this, 60 degrees is root 3 over 2. I can think of the reciprocal now. so I can get that. All right. Coastal 450. Well, coastal 450 is not on my unit circle, so I might have to think 450 minus 360 is 90 degrees. So the equivalent of that is 90 degrees. And on my unit circle, that point is 0, 1. So that's where close to 90 degrees is. So that is 0. Done. So hopefully you got the idea of that. There's lots of examples there. Okay. I'm going to show you, I'll show you one more back here. So if I was doing this, if I was looking at 300 degrees, all right, I can look at 300 degrees. 300 degrees is the point 1/2 negative root 3 over 2. So there's a cos of 300, and there's the sine of 300. I can say that is root 3 over 2 squared plus 1/2 squared. And I square those. That would be 3 over 4. Square of that is 1/4 equals 1. But if you remember this identity, it should always equal 1 anyways. Okay? So I think when we're looking at some of these things, I think one of the key things that we should be able to do is to identify the point. If we identify the point of getting that answer, we can figure out what trig ratio to use from that.